Hello to all your students. So in this video we are going to discuss about the new topic, that is probability. Now suppose if an experiment is repeated under essentially homogeneous and similar conditions, we generally come across two types of situation, or you can say two types of outcome. So the first situation is the result, or what is usually known as the outcome, is unique or certain. Okay, means the first situation is we are getting an exact and accurate answer to our question. Okay, now the second situation or second type of situation is the result is not unique but maybe one of the several possible outcomes. Okay, so at the end of experiment we have come to a conclusion that one can have option 1 can occur, or option 2 can occur, or option 3 can occur. Means in the second type of situation is we do not have a unique result. Okay, we do not have a unique result, we have got some kind of possibility that may occur. Okay, so after completion of an experiment you may get an accurate answer, or you may not get an accurate answer, you may get a possibility either. Okay, so the phenomena which is covered in the first type of situation, that when we are getting a unique answer, it is said to be a deterministic or predictable phenomena. Means by a deterministic phenomena we mean one in which the result can be predicted or certainty. Like for example, the velocity v of a particle after time t is given by the formula v equals to u plus at. Here u is the initial velocity and a is acceleration. Okay, so what we need to calculate? We need to calculate the velocity v. So if you know the values of u, that is initial velocity, the value of a, that is acceleration, is known, and the value of t, that is time, means all the thing which is present in the right hand side, if all the quantities you know, then you can get the velocity with accuracy. Okay, so this is known as deterministic phenomena or predictable value, we know the accurate answer. But the second situation, like the phenomena is covered by the second situation, which do not lend themselves to deterministic approach and are known as unpredictable or probabilistic phenomena. Like for example, in tossing a coin, one is not sure if a head or a tail will be obtained. Okay, so we cannot say, we can predict that okay, head will come or tail will come, but we cannot give any assurity. Like even if 1,000 times you are tossing a coin, we cannot say that head can occur or tail can occur. So this is known as probabilistic phenomena or unpredictable phenomena, means we cannot predict the outcome. In the previous case, for determining velocity, if the value of u, a, t, we know these three values, we can calculate v with accuracy. But when we are tossing a coin, or when we are throwing a die, we cannot say, we cannot predict the outcome. So this is known as unpredictable phenomena or probabilistic phenomena. So when you are tossing a coin, either head can occur or tail can occur. So we have got 50% chances of head, 50% chances of tail, or you can say there are half chance or getting tail and half chance for getting tail as well. Okay, so both head and tail have got half opportunity to come. Okay, so that is probabilistic. We cannot say with surety like okay, 100% head can come or 100% tail can come. We cannot say, we cannot predict actually. So probability definition is the likelihood of occurrence expressed by the ratio of the actual occurrences to that of all the possible occurrences. Okay, so probability by definition, what it is? It is the ratio. Ratio of what? Ratio of the actual occurrence. Okay, actual occurrence means you have tossed a coin and suppose head have occurred. Okay, so that is the actual occurrence. 2 means divided by all the possible occurrences. Okay, all the possible occurrences. So how many possibility are there? Two possibilities occur. What is the actual occurrence? Suppose had have occurred, means one have occurred, divided by number of possibilities are two. So 1 by 2 is the ratio over here. Okay, so probability, what it is probability? It is the occurrence which is expressed by the ratio of the actual occurrence to that of all the possible occurrences. That is probability. So probability is a measure of uncertainty. Probability is the science of how likely events are to be happen. Okay, it is to be happen. We cannot say what is going to happen. It is to be happen. So next we'll check out few definitions of various terminologies that will come across in this probability. So the very first thing is trial and event. Consider an event which, though repeated under essentially identical conditions, does not give unique results but may result in any one of the several possible outcomes. The experiment is known as trial and the outcomes are known as events or cases. Okay, so suppose you are doing some kind of experiment and you have repeated the experiment, and how many times you have done the experiment is known as trial, and what is the outcome of the experiment, that is known as event. So now if I am saying experiments means in your mind some laboratory is coming. Let us check out the examples and you will come down to earth. Throwing a die. Throwing of a die is a trial, and getting 1 or 2 or 3 or 4 or 5 or 6 is an event. Okay. And another example. Tossing of a coin is a trial, and getting head or tail is an event. Okay. Suppose you have tossed a coin. Suppose one time you have tossed a coin. So that is one trial. Suppose you got head, that is an event. Suppose in place of head you got tail, that is also an event. So whatever result, whatever outcome you got, that is an event. One more example. Drawing two cards from a pack of well shuffled cards is a trial, and getting king or queen is an event. Okay. Now we'll take an example. Suppose you are throwing a die. You got 2. One more time you have thrown a die. You got 5. So you have thrown the you have thrown this die 2 times. So 2 is the trial. In the first trial what you got? 2. In the second trial what you got? 5. So 2 and 5 are events. Okay. So throwing a die is not an what? An experiment. Okay. It is an experiment. So how many times you have performed this experiment? 2 times. So you can say 2 trial. And what is the outcome of the experiment? First time we got 2 and another time we got 5. So 2 and 5. What are these? These are known as events. Okay, trial and events. How many times you have thrown the die? 2 times. So that is trial. And what is the result? First time you got 2 and second time you got 5. So these two are events. Okay, so this is trial and event. Next term is exhaustive events. So exhaustive events, the name only says exhausted, completed. So something which is total, that is exhaustive event. Let us check out what it is exactly. The total number of possible outcomes in any trial is known as exhaustive events or exhaustive cases. For example, in tossing a coin, there are two exhaustive cases, that is head and tail. The possibility of the coin standing on an edge being ignored. Okay, so you are tossing a coin. Okay, and what all are the maximum number of possibility? Either head can come or tail can come. So we can say two exhaustive cases are possible in tossing a coin. One more example we'll check out. In throwing a die, there are 6 exhaustive cases, since any one of these 6 spaces may come. Okay, so we know on a die we have got 6 spaces, and whenever you are about to throw a die, we have got possibility of 6, means one can have come or 2 or 3 or 4 or 5 or 6. Anything can come. So what all are the maximum number of possibilities are known as exhaustive events. One more example. In drawing two cards from a pack of cards, the exhaustive number of cases is 52C2. So we say it as 52 combination 2, since two cards can be drawn out of 52 cards in 52 combination 2 ways. Okay, so in a pack of card we have got 52 number of cards. Okay, so we have got 52 possibilities, and among those 52 cards, how many cards we are drawing? Two cards. So we write it as 52 combination two ways. Okay, in my future videos you will get to know how we are solving this 52C2 or 52 combination 2 thing. Okay, now for now you should understand this thing, exhaustive event. Like suppose you are about to throw a die, so in your mind what will come? One can come, two can also come, three can also come, 4 can also come, 5 can also come, or 6 can also come. So these are the maximum number of possibilities that can come when you are about to throw a die. So this is known as exhaustive event. The maximum number of outcome that is possible, that is known as exhaustive event. Next term is favorable event or favorable cases. Now favorable means this should occur, then I will win. Okay, suppose you and any of your siblings, they are fighting for a single piece of ice cream. Okay, so you will toss and you will be like, if head comes then I will get the ice cream, but if tail comes means my sibling will get the ice cream. So you will be like, yeah, please head should come so that I should get the ice cream. So for you the favorable event will be head. If head will come, you will get the ice cream. So something like that. Okay, so let us check out what exactly favorable event is. The number of cases favorable to an event in a trial is the number of outcomes which entail the happening of the event. Okay, so it is the number of outcome. If so is the outcome, then this will be the event that is likely to occur. Like for example, in drawing a card from a pack of cards, the number of cases favorable of drawing an ACE is for ACE means in Hindi what we call Ekka, that in card A will be there. Ekka is for drawing a spade is 13. Spade means some leaf like shape will be there na in card, that is spade is 13, and for drawing red card is 26. So maybe we have got 26 number of red card, and if this will occur means you will win. Sorry, I cannot explain this example properly because I actually do not play cards, so I don't have much knowledge regarding cards. So I should skip this example. We'll check out the second example. In throwing of two dice, the number of cases favorable to getting the sum of 5 is, suppose you are throwing two die. In one die it is 4, and in second die 1 means you will get 5, and if 5 will come then you will win, or 4 and 1 combination, or 2 and 3, or 3 and 2 combination. If this kind of combination occur means 5 will occur, and if 5 will occur then you will win, something like that. Okay, so suppose you are playing a Ludo. Okay, Ludo game to you people know. I know, I have played in my childhood. So suppose you are in blue color. Okay, so in blue color you can see U is written, isn't it? Over here U is written. Now you can see one um, what we say, this horse. Horse, it is about to go to home. So for going home it require 1 2 3 4 and 5. If 5 will occur means you will win, the blue or you will win. So you are about to throw a couple of dice, means two die, and you are expecting that 5 should come. So 5 is your favorable event. If 5 will occur means an event, and what is that event? You will win, that is an event if 5 will occur to you. So your favorable event is 5. So you got 1 and 4 means you will think that in one die 1 should occur, and second die 4 will occur, then 5 will come and I will win, or else in one die 4 and 1 will occur, then I will win, or else a die 3 and 2 combination, or 2 or 3 combination, if this occur then I will win, or blue will win. Okay, so this is the favorable event, means if this will occur then I will win. So this is known as favorable event or favorable cases. Next, another term is mutually exclusive event. Mutually exclusive means if this happens then that will not happen, and if that will happen then this will not happen. If I got first rank, then and another person will get second rank, and then another person will get third rank, means no two-person will get first rank, something like that. Okay, so let us check out what is mutually exclusive event exactly means. Events are said to be mutually exclusive or incompatible if the happening of any one of them precludes the happening of all the others. That is, if no other two or more of them can happen simultaneously in the same trial. Okay, means you have, we'll check out an example. In throwing a die, all the spaces numbered 1 to 6 are mutually exclusive, since if any one of these spaces comes, the possibility of others in the same trial is ruled out. Okay? So, one time you have thrown a die, and after throwing a die, suppose 1 came. Okay, so 1 came means 2 is 2 has not come, 3 has not come, 4, 5, 6 has not come. Okay, so in single trial only one event is the outcome. Okay, so when you are throwing a die, only one has come, and if one has come, there is no chance of 2, 3, 4, 5, and 6 in that trial. Okay, if you have thrown an another time, means there are possibility that other numbers may come, but in a single trial only one can come. Similarly, in tossing a coin, the event head and tail are mutually exclusive. Okay, so you have tossed a coin and head has come. So if head has come, then tail will not come, obviously, isn't it? You have tossed a coin one time and there is one answer or one outcome. Now, what is the outcome? Head is the outcome. When head is there, tail is not there. Okay, and if tail is there, then head is not there. Both head and tail cannot come together in a single trial. Okay, so that is known as mutually exclusive event. Next term is equally likely events. Means suppose um, you're sitting for an exam, and in your classroom we have got 50 students. So all the 50 students have got equal opportunity of getting 100 out of 100 marks, or equal opportunity of getting first rank. Okay, so that is something you can understand like equally likely event. So let us check out what exactly equally likely events are. Outcomes of a trial are said to be equally likely if, taking into consideration all the relevant evidences, there is no reason to expect one in preference to the others. Okay, so all have got equal chances to win. We cannot give preference that okay, now she has win and another game that will person will win. No, nothing like that. All have got equal and likely preferences to win. Let us check out an example. In tossing an unbiased or uniform coin, head or tail are equally likely events. Okay. In throwing an unbiased die, all the 6 faces are equally likely to come. We cannot say that okay, if you throw with like Shakuni Mama, you will get 6. If you will throw like that only, you will get 3. No, there is nothing like that. We cannot predict anything. We cannot guess anything. All the faces of the die have got equal opportunity to come in the uppermost spot, means like that. Okay, so you are tossing a coin, head can come or tail can come. So both have got equal opportunity. You are throwing a die. So 1, 2, 3, 4, 5, 6, anything can come. All the 6 spaces have got equal opportunity to come. Next term is independent event. Okay, like independent event means like see, we are living in democracy. Okay, and suppose one person have become a chief minister of any state. Okay, there are chances that in the next election some other can become chief minister. There are chances that same person can become chief minister again in this another election. So that is something known as independent event. Okay, let us check out what exactly it is. Several events are said to be independent events if the happening or non-happening of an event is not affected by the supplementary knowledge concerning the occurrences of any number of the remaining events. For example, in tossing an unbiased coin, the event of getting a head in the first toss is independent of getting a head in second, third and subsequent throw. Okay. If we draw a card from a pack of well shuffled cards and replace it before drawing the second card, the result of the second card is independent of the first draw. Okay, let us omit this card wala example. We'll concentrate in the first example only, that is tossing a coin. I cannot explain the card wala. Matlab, I am not used to playing. Matlab, I never play card. Okay, I am not juari. I do not play cards. We'll consider in the first example, that is tossing a coin. Suppose once you have tossed a coin and you got head. Now second time again you have tossed a coin and again you got head. That means getting head is independent. It is nothing like, okay, one time you got head, now in second toss you will get tail. It is nothing like that. It is nothing like that. In the head we have got a queen, so I love queen, so I will get head only. Okay, you cannot see anything. Maybe first time you got head, there are chances that second time also you will get head. There are chances that third time also you may get head or you may get tail. You cannot say. It is an independent event. It is nothing that one time you got head means second time you should get tail. No, second time also you can get head. You can get tail either also. Okay, so you cannot say anything. So these are independent events. Okay, you can get head 100 times also. You cannot see anything. You actually cannot predict anything. So that is independent event. So for this reason I gave the example of chief minister. Okay, in first election one person was chief minister. In the second election maybe the same person will become chief minister, or there are chances that some another person will become chief minister. Okay, you cannot say, you cannot predict anything. That is independent event. So these were all about the various terminologies regarding the probability. Next we shall check out mathematical or classical probability. If a trial results in an exhaustive, mutually exclusive and equally likely cases, and m of them are favorable to the happening of an event E, then the probability P of happening of event E is given by, there is one equation. So first of all we'll try to understand these three lines. Okay, now what it is saying, if a trial results in an exhaustive, what is exhaustive? That is the maximum number of possibility. Like suppose you are tossing a coin, what are the maximum possibility? Head or tail. So that is two exhaustive event possible. Okay, if a trial results in an exhaustive, mutually exclusive means either head can come or tail can come. Both together in a single trial cannot come. Okay, so an exhaustive means we have got either head or tail. Mutually exclusive and equally likely cases means both head and tail have got equal opportunity to come. Okay, so if a trial results in an exhaustive, mutually exclusive and equally likely cases, and m of them are favorable. Favorable means, suppose again same example, fighting for a ice cream, you and your sibling or me and my big brother. Okay, we both are fighting for an ice cream, and if head will come means I will win. So for me the favorable event is head. Okay, again, if a trial results in an exhaustive, mutually exclusive and equally likely cases, and m of them are favorable to the happening of an event E. What is the event E? I am eating the ice cream, that is event E. Then the probability P of happening of event E. Probability of happening the event E. What is the probability of event E? And what is event E? Me eating the ice cream. So what is the probability of me eating the ice cream? That is given by the equation P of E. P of E is me eating ice cream is equals to favorable number of cases. If head occurs, that is one case, divided by the exhaustive number of cases. What are the exhaustive number? Head and tail. So it is given by m divided by n. Okay. So P is the probability of occurrence, that is success. If I am eating ice cream, that is my success. Okay, so you are tossing a coin and if head occurs, means that will be success. And Q is the probability of non-occurrence, that is failure, that is head if it is not occurring. Okay, now listen to my words very carefully. Now if head is not occurring means tail is occurring, isn't it? But Q is not equals to occurrence of tail. You should remember, Q is not equals to occurrence of tail. Q is equals to non-occurrence of head. Okay, actually both mean same, but what you should make in your mind is Q means non-occurrence. Okay, P means occurrence, Q means non-occurrence. P means head, Q is no head. Okay, now P, the probability of P is 1 by 2, half chances of success and half chances of failure. So when you add P plus Q, so half plus half, how much it will be? It will be 1. Okay, so the probability of success plus the probability of failure is always equals to 1. Okay, so always we have got 50% chance of success and 50% chances of failure. Fine. Let us have an example. What is the chance that a leap year selected at random will contain 53 Sundays? Okay, so we know we have got leap year once in 4 years, and what exactly happens in leap year? In leap year we have got 366 days. Now among these 366 days we have got 52 complete weeks. Sunday to Saturday we have got 52 complete weeks plus 2 days extra. Okay, now 52 complete weeks means we have got 52 Sundays also. So what is the possibility that the extra 2 days, in that extra 2 days Sunday should also occur, and in that particular leap year there should be 53 Sundays. Okay, so this probability you need to calculate. Probability of a leap year to contain 53 Sundays, that we need to calculate. Okay, so next we are coming to solution. So the following are the possible combinations for the extra 2 years, right? One combination is the extra 2 years may be Sunday and Monday. Next possibility is 2 extra days may be Monday and Tuesday. Next possibility is the extra 2 days may be Tuesday and Wednesday. Next possibility is extra 2 days may be Wednesday and Thursday. Next possibility is the extra 2 days may be Thursday and Friday, or it may be Friday and Saturday, or it may be Saturday and Sunday. So how many possibilities we have got? We have got 7 possibilities. Okay, so you can say we have got 7 exhaustive events. Okay, so in order that leap year selected at random should contain 53 Sundays. So if we want 53 Sundays means it should be Sunday and Monday or Saturday and Sunday. So we have got 2 favorable events out of 7 exhaustive events. So we how many exhaustive events we have got? We have got 7. And what is the favorable events? The events that should contain Sunday. So you can say the first event and the 7th event contains Sunday. So that is favorable events. So probability of cutting E over here is 53 Sundays is equals to favorable number of cases divided by the exhaustive number of cases. So how many are favorable number of cases? First and 7, that is 2 divided by 7. So 0.28 is the probability, or you can say 28% is the probability of getting 53 Sundays in a leap year. Now we know P plus Q equals to 1. So if we want to calculate Q, means Q equals to 1 minus P, that is 1 minus 0.28, that is 0.72. Now what is Q? Q is the occurrence of non-occurrence of the probability of non-occurrence, probability of not getting a 53 Sundays. So that is 0.72, or you can say 72%. So you can say in a leap year we have got 28% chances of getting 53 Sundays and 72% chances of not getting Sundays. Okay. Next we'll have one more example. I'm taking a pharmaceutical example this time. Suppose there are 10 lakh tablets in a batch are tested for defects. And among these 10 lakh tablets, we have got 50,000 tablets which are chipped, 40,000 tablets which are discolored, and 30,000 tablets that are rough. Okay, so first of all, we'll check the probability of chipped, discolored, and rough. Okay, so P chipped you are writing is equals to favorable number of events, which is 50,000, divided by the exhaustive events. Means exhaustive events means the total number of tablets, which are 10 lakh. So we'll get 0.05, or you can say 5% of tablets are chipped. Similarly, probability of discolored, which is 0.04, or you can say 4%. Similarly, probability of rough, favorable number is 30,000 divided by the exhaustive number is 10 lakhs. So 0.03, or you can see 3%. Okay. So we have got means among the 10 lakh tablets, 0.05 have got probability to be chipped, 0.04 have got probability to be discolored, and 0.03 tablets have got probability to be roughened outer surface. Next, suppose all the defects are mutually exclusive. All the defects are mutually exclusive means the tablets they are either they are only chipped, or they are only discolored, or they are only rough. Okay, there is no single tablet which is rough as well as discolored, or rough and chipped, or chipped and discolored. Okay, a tablet it is only chipped, or a tablet it is only discolored, or a tablet which is only rough. So this is mutually exclusive cases. So we'll write it as probability of chipped plus probability of discolored plus probability of rough. So find the probability of choosing a defective tablet. So probability of choosing a defective tablet equals to probability of chipped plus discolored plus rough. So you need to add all these things. So you will get 0.12. So we have got 0.12 probability of defective tablets. Okay, or you can say 12% of defective tablets. So this is P. So our success over here is defective. Okay. Our success over here is to get a defective tablet. Next, we know P plus Q equals to 1, and if you want to calculate Q over here is probability of non-occurrence, means probability of not getting a defective tablet. So you can say probability of getting an acceptable tablet is Q. So you will get 0.88. So probability of getting an acceptable tablet is 0.88, or you can say 88%. Okay. So you will make a table like this, and if you will write it in percentage, so probability of chipped is 5%, probability of getting a discolored tablet is 4%, probability of getting a rough tablet is 3%. And for defective and acceptable, we have got 12% of defective tablets and 88% of acceptable tablets. So you can represent it in a graphical manner also, like 88% are acceptable and 12% are defective, and among those 12%, 5% chipped, 4% are discolored, and 3% are rough. Or in this manner, see how beautifully you can represent this thing. 88% is acceptable and 12% is defective, and among those defective, 5% is chipped, 4% discolored, and 3% rough. Okay, can you see how beautifully you can represent this thing with the help of this probability distribution? Isn't it? Now, a different condition you will take now. Suppose if chipped and discoloration are not mutually exclusive events, means there are few tablets which are chipped as well as discolored. Okay, now you imagine there are few tablets that are only chipped. There are few tablets which are only discolored. There are few tablets which are chipped as well as discolored. Okay, so when a tablet is chipped as well as discolored means these are not mutually exclusive. Okay, if they are mutually exclusive means either a tablet is chipped or discolored, but here they are not mutually exclusive means the tablets are chipped as well as discolored. Okay, so then the equation will be probability of chipped or discolored is equals to probability of chipped plus discolored minus chipped and discolored. Okay, so suppose 20,000 tablets are both chipped as well as discolored. So probability of chipped and discolored is equals to favorable divided by the exhaustive. So favorable is 20,000 divided by exhaustive is 10 lakh. So we have got 0.02, or you can say 2% of the tablets are such they are chipped as well as discolored. Okay. So now find the probability of chipped or discolored. Okay, so you can use this formula. Chipped is 0.05, only discolored is 0.04 minus chipped and discolored is 0.02. So you will get the value of 0.07, or you can say 7% of the tablets have the defect of chipped or discolored. Okay, so we have got 7% of tablets which are only chipped and only discolored. We have got 2% of tablets which are chipped as well as discolored. Okay, so 7% are mutually exclusive and 2% are not mutually exclusive. Next, what is the probability of getting a defective tablet, which is probability of chipped plus discolored plus rough minus probability of chipped and discolored. Okay, so you solve this thing, so we'll get 0.10, or you can say 10% of the tablets are defective. Now probability of getting an acceptable or not defective is 90. Okay, so 90% of the tablets are acceptable. So you can make a tabular column like this: chipped, discolored, chipped and discolored. So when you take the percentage, 5% are only chipped, 4% are only discolored, and 2% are chipped as well as discolored. Now the probability for defective and acceptable in terms of percentage: 10% of tablets are defective and 90% of tablets are acceptable. And in graphical manner you can see 90% of tablets are acceptable and 10% are defective. Now among the defective, 3% is only chipped. Okay, 2% is only discolored and 2% is chipped as well as discolored. Okay, so as you can see in the table over here, chipped is 5%, isn't it? Chipped is 5%, and over here you can see only chipped is 3%. Chipped as well as discolored is 2%. So 3 plus 2 will become 5%. Similarly over here only discolored is 4%, isn't it? Only discolored is 4%. And over here you can see only discolored is 2% and this 2% is chipped as well as discolored. So 2 plus 2 will become 4, isn't it? So in this manner you can see. So chipped and discolored is 2%. Now 3 plus 2 plus 2, it will become 7%. But how much are defective? 10%. So remaining 3% are rough. Okay, so you can see this is how you can see a short probability distribution. Okay, so this is all about my today's video regarding the probability. It is just an introduction to probability. In my future videos we'll continue this topic. We need to discuss about binomial distribution, Poisson's distribution and normal distribution. Okay, so for now I hope you people found this video helpful. Thank you for watching.